Hi, and welcome to this look at an applied exam question which is about predicting isomers of aromatic compounds. So it tells you the mass spectrum of an aromatic compound is found to have a molecular ion peak at MZ value of 106. Elemental analysis showed the compound had the following composition by mass: carbon 90.56 and hydrogen 9.44. So first of all, double checking that both of those add up to 100, which they do. The next thing to do is to get into the question itself. They want you to use the data to find the molecular formula of the aromatic compound. So firstly, the fact it's aromatic means it contains a benzene ring. Secondly, the fact it's a hydrocarbon means it just contains carbon and hydrogen atoms and nothing else. And then the molecular ion peak at MZ value of 106 means it's got an MR of 106 grams per mole. So the first thing is to divide the percentages by the relative molecular mass for each element to get a ratio. So that gives us 7.546 for carbon and 9.44 for hydrogen. Now obviously there aren't a whole number ratio, so the next thing to do is to divide the ratio by the smallest number, which happens to be 7.546, to hopefully get a whole number ratio. Now in this case that doesn't work. So what we've got to do is multiply it up to get rid of the fraction, the 0.25. So that gives us C4H5 as our empirical formula. Now the empirical formula isn't the same as a molecular formula. The empirical formula is the simplest whole number ratio. So knowing that the MR is 106 grams, you divide that by 53 grams per mole, which is the mass of the empirical formula, to get 2, which means you must multiply everything up by 2. So that gives us C8H10 as our molecular formula. So then it says, a student realized that the calculated molecular formula could have a number of different structural isomers. They want you to draw all the possible structural isomers that contain a benzene ring. So what that means is that out of our molecular formula C8H10, the benzene ring will constitute C6H5. The reason it doesn't constitute C6H6 is because there's more than 6 carbons and more than 6 hydrogens. So therefore, there must be a substitution somewhere in the benzene ring. Whenever you get a substitution in a benzene ring, that drops it down to C6H5 and then something else instead of C6H6. So these are the possible options that we have. So hence there's 4 marks available. Then it says, in the presence of concentrated nitric acid and concentrated sulfuric acid, one of the isomers reacts to give one mononitrated compound B. Identify A and B. So the first thing to do is to notice that the concentrated nitric acid and concentrated sulfuric acid means that the NO2 group is substituted directly onto the benzene ring. In other words, a hydrogen is taken off and the NO2 comes on. And it's mononitrated, so that means it only happens in one location, not twice or 3 times. So having a look at our different options, so we're going to try and make a mononitrated compound, but it says only one. So therefore, we've got to be a bit careful. So it can't be ethyl benzene because there's actually 3 possible locations of the nitro group relative to CH3. I'll go through them in a moment. For the same reason, it can't be 1,2-dimethyl benzene, and it also can't be 1,3-dimethyl benzene. So let's look at the numbering. You've got 2, 3, 4 positions. You've got positions 2 and 3 relative to the CH3, and then you've got positions 2 and 3 relative to the CH3 again. But in the other one, on the far right hand side, wherever you put the nitro group, it's going to be at position 2 relative to a CH3. So that must be the isomer that we're talking about. So essentially what they want you to do is to identify that isomer and then nitrate it. So the mononitration will go on in any of those 4 spare places, and all of them would lead to 2 nitro, 1,4-dimethyl benzene. Okay, hopefully this has been a useful look at this rather applied question. Until next time, thanks for listening and see you soon.